Okay, so here we are. We are going to do your 6.4 video lesson. It is all about factoring. We did factoring in the last unit, so a lot of today is going to be a little bit of a review. So to start, in 6.3, we talked about something called synthetic substitution. And when you did synthetic substitution, we used synthetic division to kind of plug a value in. So these first examples say we're trying to figure out if the binomial given, or if the factor given, is actually a factor. And if you remember from 6.3, we plugged something in, we evaluated it, and then whatever the remainder was our answer. That's also why it's called the remainder theorem. However, if we get a remainder of 0, that means that we're talking about a factor. So what I have to do is I have to plug these numbers in, so x minus 3 equals 0. So x equals 3. Remember that when we plug something in for synthetic division, we always use whatever the 0 is. So my coefficients are 1, 2, negative 3. So if I plug it in, bring down the first value as usual. 1 times 3 is 3. 2 plus 3 is 5. 5 times 3 is 15. 12. So because we got 12 and we did not get 0, x minus 3 is not a factor. Okay, well, what about over here? I get x plus 4 equals 0. So x equals negative 4. I come over here and I plug it into synthetic division, make sure I have every term represented. I have a 2x to the 4th, 8x cubed. I have no x squareds, so 0 of them. 2 and then 8. So I plug it in, bring down the 2. 2 times negative 4 is negative 8. 8 plus negative 8 is 0. 0 times negative 4 is 0. 0 plus 0 is 0. 0 times negative 4 is 0. Then 2. 2 times negative 4 is negative 8. Hey, look at that. We got a remainder of 0, meaning x plus 4 is a factor. Now this is going to become more useful as we talk about the rational root theorem, but for right now we're just practicing finding if things are or are not factors. And from here we're going to practice some types of factoring that you've done before, just with bigger degrees. So the first one is always your first step. It's factoring out a greatest common factor. You're looking for the things that they share. So if I look at example 3, I notice that they share a 2 and then x squared. So if I pull out a 2x squared from both of them, I'm left with x, because 2x squared times x is 2x cubed, plus 2, because the x squared goes away, and I'm left with a 2. And that's it for this one. I'm just pulling out a greatest common factor. Again, 2x cubed and 4x squared share a 2x squared. So I pulled it out, and then whatever was left stayed in the parentheses. Over here, it's a little more difficult. It looks like I have a 4, a 3, and a 2. And those numbers don't really share anything, so there's no number part of the greatest common factor. I look at the a's next. I have 1a, a squared, and a. So they all share an a. Then I have b cubed, b, and b. So they also all share a b. So if I pull out ab, which is my greatest common factor, I'm left with 4b squared, because I originally had 3 b's, plus 3a plus 2, because I got rid of both a and b in the last one. And you can always double check. If you think you have the greatest common factor and then you notice that they continue to share something, you can pull that out again. But in this case, all they shared was 1a and 1b, and when you factor them out, you're left with 4b squared plus 3a plus 2. So not too bad so far. But then you notice factoring by grouping. Well, we only really did factoring by grouping with the big X when we factor in quadratics. So when we do factoring by grouping with 3-term things or degree 3 things, you're going to automatically start by putting the first 2 together and the last 2 together. Now, if you notice, out of the first 2, I can pull out an x squared, and I'm left with x plus 3. Out of the second 2, I can pull out a negative 4, and I'm also left with x plus 3. Remember, we did factor by grouping right if we get the same thing. So then you put what's outside of the parentheses in 1, x squared minus 4, and then x plus 3. However, if you remember from Chapter 5, I told you those Chapter 5 skills are going to be very, very important in this one. I have a difference of squares here. So that factors to be x minus 2, x plus 2, x plus 3. So now I have completely factored something that's a degree 3, something that we might not have done before. One more factoring by grouping example is I group these 2 together and these 2 together. I can only do this in standard form, by the way, but they're already in standard forms. Out of the first 2, I can factor out an x squared. So I'm left with x squared times 2x plus 1. Out of these 2, I can only factor out a 2 and then 2x plus 1. So I am left with x squared plus 2 in one set of parentheses, and 2x, oh my gosh, iPad, 2x plus 1 in the other set of parentheses. Now, over here, we could change x squared minus 4 because it was a difference of squares. This is not a difference, it is not subtraction. So because we're not dealing with imaginary numbers just yet in this chapter, I'm going to leave it alone. That is fully factored. So we have this is fully factored for that, for example 7, and this is fully factored for example 8. Did I skip example numbers? Oh, I totally did. Whatever. So that is factoring by grouping. Now, we're going to move on to factoring things that look like quadratics. Factoring things that look like quadratics, but they're not exactly quadratics. So if you notice, this is an x to the 4th, not an x squared. For those of you who still don't know what I mean when I say quadratic, it means x squared. But it's kind of in the form, like, it kind of eerily looks like, excuse me, skip that cloud. It kind of eerily looks like 2x squared minus 5x minus 7. It looks like kind of the same form. So what we're going to do is we're going to try to factor this like we would a quadratic. Like we would a quadratic. So I'm going to do my x. And I get negative 14x to the 4th on top, and negative 5x squared on the bottom. So I'm looking for something that multiplies to negative 14x to the 4th and adds to negative 5x squared. If you guessed negative 7x squared and 4, lies, 2x squared, you would be correct. So we take those, and we get 2x to the 4th plus 2x squared. Remember, we replace the middle term with whatever we get, minus 7x squared, minus 7. And now I can factor by grouping, just like I did in the last set of examples. So in the first 2, I can factor out a 2x squared, and I'm left with x squared plus 1. Out of the second 2, I can factor out a negative 7, and I'm left with x squared plus 1. Now that I have done factored by grouping, I put outside of the parentheses in one set 2x squared minus 7, and inside in the other set x squared plus 1, and I am done. So let's do one more example. Again, always feel like you can pause the video if you want to try it on your own first, or you can just continue to watch along with me. Set up my x. So I have 12x to the 6th on top and negative 7x cubed on the bottom. It looks like negative 4x cubed and negative 3x cubed multiplied at the top. So I change it to 12x to the 6th minus 4x cubed minus 3x. Oops, I was supposed to write a cubed here. Cubed plus 1. And then I group these together, and I group these together. So out of these two, I factor a 4x cubed to get 3x squared minus 1. And out of these two, I can factor out a negative 1 to get x cubed. Darn it, me and the cubes today. X cubed minus 1. So then I put whatever's on the outside in one set, 4x cubed minus 1, and 3x cubed minus 1. So same process as factoring quadratics, just with bigger exponents. Notice that this only works for things that are like, so it starts with 6th and then 3rd, which is half, and then there's no x term. So 6, 3, 0. This one over here is 4, 2, 0, because 2 is half of 4. It would work for 8, 4, 0. It would work for 12, 6, 0. Anything where the middle term is half of the degree of the first term. So two more types of factoring, one you've seen before and one you haven't. In this one, this is a reminder, we used this one earlier from Unit 5, where if you have something squared minus something squared, you get a minus b times a plus b, just one of those formulas you had to memorize. So when we look at example 11, the first step we always do is factor out a greatest common factor. In this case, they both share an x squared minus 144. From there, I can factor that x squared minus 144, because there's a difference of squares, to x minus 12, x plus 12. Woo! Not too shabby. But if you come over here, you notice, oh my gosh, this one's way bigger than the last one. Well, 16 and 81 don't share anything, but they do share an x to the 4th. So I can at least take that out, 16x to the 4th minus 81. So even though it's not directly squared, I still know that this is a difference of squares, because x squared is x to the 4th. I don't know if that makes sense, but I'll say it one more time. X squared is x to the 4th. So I can change this to x to the 4th times 4x squared minus 9 and 4x squared plus 9. Because the square root of 16 is 4, the square root of x to the 4th is x squared, and then the square root of 81 is 9, so I can split that up. But if you notice, I snuck another one in there, because the square root of 4 is 2, and the square root of 9 is 3. So my final answer is going to still be the x to the 4th on the outside, times 2x minus 3, and 2x plus 3, and 4x squared plus 9. We can't factor the 4x squared plus 9 because it's imaginary. It's not a difference yet. Last but not least are some formulas that you will have to know, will have to memorize. There's no shortcut to these. This is just a formula you have to know. So if you have something cubed minus something cubed, it's called the sum and difference of cubes formula. You have, oops, I used x, not a and b. The formula to factor that would be x minus a times x squared. Oh my gosh, Mr. Ducharme. X squared plus x times a plus a squared. Now, some people remember this by saying the first part has the same sign and then different plus. Some people remember this as same, different, plus, same, different, sign, plus. And this does work for the other one too, because if we write it in the other formula, you have the same sign, x plus a, because it started as a plus, a different sign, x squared minus xa, and then plus a squared. That a squared is always added. So it's always the same sign, same, different, plus from the original sign used. So if I were to apply this formula, I notice that I have an x and 125. Well, what's the cubed root of 125? That's something that I might not know. So for this unit, I am going to expect you to know negative 5 through 5 cubed. Negative 5, negative 4, negative 3, negative 2, negative 1, 0, and then 1, 2, 3, 4, 5. So if I expect you to know all of these cubed, what are they? You can plug them into your calculator if you'd like, but I'm also just going to go down the row. Negative 5 cubed is negative 125. Woo. Negative 4 cubed is negative 64. Negative 3 cubed is negative 27. Negative 2 cubed is negative 8. Negative 1 cubed is negative 1. 0 cubed is 0. And then just the reverse. 1 cubed is 1. 2 cubed is 8. 3 cubed is 27. 4 cubed is 64. And 5 cubed is 125. So if I actually use those, I would look here and notice that I have an x cubed minus 5 cubed. So I'm going to use my difference formula, the one with the minus in the middle, and turn that into x minus 5. If we write that, we have, if a is 5 in this case. And then we have x squared, different sign from the original, plus 5x plus 25. And then that's how you factor with the formula. A quick note is that you did it right if you can't factor this part. This part should be unfactorable without imaginary numbers or rational numbers. We'll talk about that later, but if you know you did it wrong, if you can automatically factor that part. So one more. If I look at example 14 and I compare it to my number chart above, I know that this is 2x cubed plus 3 cubed. So in this case, my first part is 2x, not just x. So when I factor it, I have to do 2x plus 3. I have to square 2x, which is 4x squared. And then 2x times 3 is 6x. So again, just so for those of you who need me to make a note, I did 2x squared for that part. And for this part, I did 2x times 3. And then I'm going to add 3 squared, which is 9. And that is my factored form using the formula. So again, some of you are going to look at these examples and be like, great, I had no idea what just happened. But those are memorization formulas. Unfortunately, other than the same different plus, I have no other tips for remembrance besides that. This is the end of the first video. There is a second video that has kind of a reminder of all the different ways we've factored so far. You feel free to try those examples first and then watch the video, or again, you can watch along. It's up to you. I would probably recommend that you try them first. Thanks for watching.